Problem number 5. Nadia wants to plant a large circular flower garden in her backyard. She drew the diagram below with her compass. The shaded areas will be planted in purple petunias, and the white areas will be planted in white petunias. If the diameter of the big circle is 8 feet, find the total area of the part planted in purple petunias. Express your answer in terms of pi and then use a calculator to get a numerical value. So, alright, well, first of all, the only information that we're given is the diameter of the large circle, well, other than the drawing, of course, and the diameter of the large circle is 8 feet. Okay, and make sure you recognize this says diameter. Okay, so that's the whole distance across the circle. So that's this whole thing across here. And you need to recognize that because most of our area formulas, or all of our area formulas for circles involve the radius. So if the diameter is 8 feet, then the radius is 4 feet. Okay? So I'm going to say, let's see, how should I say this? R is the radius of the large circle, and that's equal to 4 feet. Okay? So don't forget that's 4 feet, not 8 feet. Alright. So, well, how can we approach this? We have the big circle, and then we have these smaller circles, but they also have this overlapping region. So what I think I want to do, I want to take the area of the large circle and subtract out the areas of the smaller circles. But then I have to be careful because each time I subtract the area of a smaller circle, then I also subtract this little football-shaped wedge here, and I don't want to. So I end up subtracting 2 football shapes for each circle. So I end up subtracting 8 of those football shapes, but I have to add them back in afterwards because I didn't want to subtract any of them. I want to keep those football shapes in there. So let's I'm going to define a few things here. I'm going to call A1 is equal to the area of the large circle, and I'm going to call A2 the area of the small circles, and then I'm actually going to define another area called A3, which is going to be the area of a football shaped region. Okay, that's one of these here. So I guess that would be an American football. Those of you who aren't in America might not recognize that as a football shape, but here in America it looks like a football. So all right, so the large circle is pretty easy, right? Because we're given the radius. So A1, the area of a circle is just pi r squared. So pi times 4 squared, and that's just 16 pi, and that's square feet. So that part's easy. And actually the area of the smaller circles, those are easy too, because you can see, well, actually I'm going to kind of impose a grid here. The diameter of each of the small circles, well, you can see we have 2 small circles that span the diameter of the large circle. So each of those smaller circles has to be half of the large circle. So we've got here diameters of 4, which means the radius of 2. So if I were to divide these circles up like this, I'm just going to draw kind of a grid on here. Then you can see that so this is 2, this is 2, this is 2, this is 2. So the radius of the small circle is 2. Okay, and that's, you know, just because all these circles are the same shape and size. I guess I didn't say they were congruent, but by the drawing they, you know, you can see that they're pretty much congruent. So we'll assume they're congruent circles. And the radius of these small circles is 2. And and so we can find the area of a small circle pretty easily. We can just take pi times 2 squared, okay, and that's equal to 4 pi square feet. Okay, so like I said before, my strategy for solving this is to take the area of the big circle and subtract the 4 smaller circles, but then I have to add back in the football shapes. And I have to take into account how many times I subtract them when I subtract the area of the smaller circles. So each time that I subtract a small circle, I'm subtracting 2 of these football shapes. Okay? So each of these football shapes gets subtracted twice, okay? Because they are the overlapping region of 2 circles. Okay? So we're going to have to add back in 8 of the A3s, okay, because we're subtracting them 8 times when we subtract the area of the larger circle. And the interesting thing here is that if we have 16 pi for the area of the large circle, and 4 times 4 pi is 16 pi. So it's interesting that the area of the large circle is the same as the area of 4 of these smaller circles. So those cancel out. So what we're left with is 8 of the football-shaped regions, and that will be the area of the shaded region. And it's interesting too because, you know, these 4 football shapes are congruent, and these funny shapes here outside along the edges of the large circle, those have to be congruent. So, you know, it turns out that actually the area of a football shape is the same as the area of these shapes along the outside of the circle. So, all right, so let's figure out what's the area of that football shape. And what I want to do here, you can see I've got a square. It's a 2 by 2 square. And if I were to, I could divide that along the diagonal, which would divide the football shape in half. And I think what I want to do then is figure out what half of that football shape looks like, and then I can just double it. So let me redraw that square, that 2 by 2 square down here. Okay, so let me see if I can actually draw reasonably straight lines here. Alright, so there's a square, and I'm going to divide it in half, and this is what half of that football shape looks like. So it's this arc here. So this is the area that I want to find. Okay, so what is that? It's the area of a quarter circle minus the area of the triangle. Okay, so the area of the quarter circle is going to be 1/4 of pi r squared, and this is 2, right? So this is pi times 2 squared. Okay, so it's the whole circle would have been 4 pi, but then we want to take 1/4 of it because we're only dealing with quarter of a circle. And then we're subtracting out this triangular region, which is a height of 2 and a base of 2. Okay, so that's going to be what? That's going to be 1/2 base times height. Alright, so essentially we've got, okay, so 2 squared is 4, and then we have 1/4 of 4 is just 1, so we have pi minus, so 1/2 of 2 is 1 times 2, so pi minus 2. So the area of half of the football shape region is pi minus 2, which means then that the whole football shape, which is A3, is equal to 2 pi minus 4. Alright? So then, all we want to find is 8 times the football shaped region. Okay? So, the area that we're looking for is 8 times 2 pi minus 4, which is equal to 16 pi minus 32. And that's the number of square feet in this diagram that is shaded. Okay? So, and if we want to plug that into a calculator and find a numerical value, I got 18.27, okay, when I round it to 2 decimal places, and that's in square feet. Alright, so 18.27 square feet, and so that's our answer, or 16 pi minus 32. And that's the area that we want to plant in purple petunias. And the rest is going to be white. So we could find the white area. And actually that wouldn't be too hard to figure out, would it? Because the whole thing is 16 pi. And we've got 16 pi minus 32 square feet. So the 32 square feet are planted in white petunias. So, that would be really pretty, wouldn't it? It would be, I'd like to see that garden when it's done. Especially, you know, if it were down low where you could see it, or on the side of a hill, you know, that would be really pretty. So, so anyway, get out your, you know, all you'd have to do is take a stick, put it in the center, and then take a string and attach it to that stick, and trace out your 4-foot radius, large circle, and then you could use that same center and that same stick, only make your radius 2, and you could then put your stick 2 feet away from the center and trace out these other circles here, and then go buy your plants, go get your petunias, and start planting. That would be pretty. So, alright, there's your answer.